Hello students, we're going to do Chapter 7, Section 1 notes today. So today we're going to learn how to balance chemical equations. First, when we balance chemical equations, we need to make sure we are paying attention to the law of conservation of mass, which states mass is neither created nor destroyed during a chemical reaction. That means that the mass of the reactants must be equal to the mass of the products. Now, I know we haven't gone through what reactants and products mean yet, but we will shortly. So if you start with 10 grams of reactants, you must end with 10 grams of products. Chemical equations, they're used to show the reactants and products involved in the chemical reaction. So the reactants are going to be on the left side of the arrow and the products are going to be on the right. What the reactants means, that just means the starting substance, and then the products, that just means the ending substance. And this arrow, that arrow means to yield or to make. So the H and the Cl would be the reactants and the HCl would be the product. Now, a few things about balancing equations. Coefficients. Coefficients are numbers written in front of a formula to show the amount needed for that formula. So in this equation, when water breaks down into hydrogen and oxygen, the 2's are your coefficients. The 2 H2O means that 2 water molecules are needed, and it produces 2 hydrogen and 1 oxygen. So if there isn't a coefficient, that just means 1. In order for an equation to be balanced, there must be an equal amount of each element on both sides of the equation. That's why it satisfies the law of conservation of mass. So here is an example. We have Al plus O2 yielding Al2O3. In the reactant side, which is on the left side of the arrow, we've got 1 aluminum and we have 2 oxygen. On the product side, there's 2 aluminum and 3 oxygen. So you want to use coefficients to balance the elements. Never change the subscripts. So now here's the same equation with the coefficients to make it balanced. And we will go through examples. This is just one to show you. So we'll put a 4 in front of the Al so that 4 times 1 is 4Al on the left. And then on the other side, we're putting a 2 in front of the Al2O3 because 2 times the 2 aluminum is 4 aluminum. So now there's 4 aluminum on both sides. We'll put a 3 in front of the O2 to make 6 oxygen. 3 times 2 is 6. And then that 2 in front of the Al2O3 goes to both the Al and the O. And so that means 2 times 3 is 6 oxygen. Now by using the coefficients, there are 4 aluminum on both sides and 6 oxygens on both sides. So now we're going to practice. For the first one, I realized there was a mistake, so I changed it. For the equations, when we balance them, I will put lines in front of the compounds that do need coefficients. If there isn't a line in front of it, it does not need a coefficient. So for the first one, just to see what it is anyway without the lines, I first look at the first element that you have. So we've got magnesium. So we've got 1 magnesium on this side and 1 on that side, so that is balanced. Then we've got F. There's 2 F's on the left of the arrow, and there's 1 F on the right of the arrow. So we're going to put a 2 in front, because we can't change the subscript, so we're going to put a 2 in the blank. So now that there's 2 times the 1 F will give you 2 F's. There's 2 lithium on this side. There was only 1 lithium, but because of the 2 in the coefficient, there's 2 lithium. 2 times 1 is 2. Then notice this, we've got CO3. This is a polyatomic ion. And since the polyatomic ion stays together, we are going to balance it together. There's 1 CO3 on the left and there's 1 CO3 on the right side of the arrow. So this is now balanced. Let's try the second one. The second one, we've got 4 P's on the left and 2 P's on the right. So to balance that, we need to increase the right-hand side, and we need to get it to 4. So 2 times 2 is 4. Now, let's look at the oxygen. There's 2 oxygen on the left, and there are 6 oxygen on the right, because 2 times 3 is 6. And so to get this 2 up to 6, we would want to put a 3 in front of it, because 3 times 2 is 6. So I guess there's a mistake on this one as well, because I would not need the blank in front of the P4. That one I do not need. You should pause and try to do the last one by yourself. So C3H8 plus O2 yields CO2 plus H2O. For these, if you see something that starts with a C and an H, I always start with the C first, then the H, and then do the oxygen last. So we're going to start with the C. There's 3 carbon on the left, and there's only 1 on the right. So we're going to put a 3 in front of the CO2. Now that's because 3 times 1 carbon is 3. Now there's 8 hydrogen on the left. There's 2 on the right. And so we want to get it to 8. So 2 times 4 is 8. Now we need to balance the oxygen. Notice on the right-hand side, there are oxygen in 2 spots. There's oxygen here, and there's oxygen here. And there's a plus sign in the middle, so you add them together. So there's 2 times 3, there's 6 oxygen here. And then 1 times 4, there's 4 oxygen there, so there's a total of 10 oxygen on the right. There's only 2 oxygen on the left. So we need to get that to 10. So 2 times what is 10? 2 times 5 is 10.